All right, so we are going to look at sections 11.21 and 11.2. So for 11.1, we're going to start here with some definitions. So a polygon, you know, is a two-dimensional figure. So a polyhedron is a three-dimensional figure whose surfaces are polygons. The face is each polygon of a polyhedron. Edge is a segment that is formed by the intersection of two faces. Vertex is a point where three or more edges intersect. Okay, so here's an example of a polyhedron. So there's 6 faces here. Each face is a polygon, so we've got some rectangles and then we've got 2 squares there. The edge is the segment that's formed by the intersection of 2 faces, and then the vertex is the point at which 3 or more edges intersect. So in this one right here, in this investigation, you want to count the number of faces, vertices, and edges of each polyhedron. So as an example, this one has, so this is a square pyramid, so there has a bottom face, and then there's 4 triangles on the side, so 5 faces. The vertices, there's 1, 2, 3, 4, and then the one at the top, so there's 5 vertices. And then the edges, there's 1, 2, 3, 4 going around the base, but then there's also 1, 2, 3, 4 going around those triangles up there. So that should be 8 altogether. So go ahead and do the same thing for the other ones. So what you want to do right now is you can pause the video and think for yourself as opposed to waiting for me to just give you the answer. So pause, think, do these 2 problems, and then play the video again. Welcome back, because I know you paused the video. So these are the answers here. So there is a relationship here. So the sum of the number of faces and the vertices of the polyhedron is 2 more than the number of edges. So face plus vertices equals 2 plus the number of edges. So in this example right here, you want to find the faces. You know that you have 20 vertices. You know you have 30 edges. So I do the math here, and I end up with 12. This one right here, you have 20 faces, 12 vertices. You don't know how many edges you have. Do the math here, you get 30 edges. Okay? It's a pretty cool relationship there. All right, if we look at the back thing here just talks about cross-section. So the cross-section here, it says the intersection of a solid and a plane is called the cross-section. So right here we have a prism here. If we put a piece of paper down it, the cross-section right here is this triangle. Okay? So in this one you have a cylinder. So if you slice that cylinder, what this looks like right here is it looks like a rectangle. So this one asks for 2. It says for this solid down here in a horizontal plane. So if I put a plane in here and I cross-section that, what I end up cutting here is a circle. So I get a circle this way. If I cut it the other direction, I'll just draw a straight line. If you cut it this way and you think about what it's going to look like down the middle, so it's going to be wider at the top than it is at the bottom, and the sides come down. So that looks like a trapezoid. Okay, so there's your 11.1 homework. All right, and then we're going to look at 11.2. All right, so 11.2. All right, what we do now is we're going to start to talk about how we can find lateral area and surface area. So we need to define a bunch of things here. So a prism is a polyhedron with 2 congruent parallel faces called bases. Okay, So here's your prism here. These right here are parallel to each other, so those are my bases. These other sides right here are faces. We call them the lateral faces. This is a lateral edge here. This is a prism, but when you talk about a prism, you usually define it by the shape of the base. So it's a pentagonal prism. Again, the bases are always the parallel faces. So that is a triangular prism. And then we have 3 lateral faces, and we have that lateral edge there. Sometimes kids get confused. This isn't going to be that great. So if I had a prism like this, some kids try to say that this is the base, not the base. Remember, the base always has to have the parallel faces. So in this one right here, those 2 triangles would be my parallel faces. So those would be my 2 bases, okay? The altitude is a perpendicular segment that joins the planes of the bases. The height is the length of an altitude. So again, in the right prism, this right here would be my altitude. It's because I'm joining the 2 bases. And the height there is just the length of that. So that's the altitude. This one right here, the bases are the 2 trapezoids. So this is my altitude. So then if I found the length of it, that would be my height. An oblique prism just means it's slanted. So, but we still think about that altitude as being perpendicular, just like we would with an obtuse triangle. So here's your altitude, so the length of that would be the height. Same thing here, the length of that would be the height, okay? All right, the lateral area is the sum of the area of the lateral faces. So no bases when you're finding the lateral area. The surface area is the sum of the lateral area and the area of the 2 bases. All right, using a net to find surface area. So if you remember back in chapter 1, we talked about nets. So if I drew this one right here, there are these, again, this is that sideways one. So these right here are your bases. Those are the ones that are parallel to each other. And then I have 3 faces that are all actually rectangles. So if I draw my net, here's my net. There's my 2 bases there. So this is 5, this is 5, this is 6, this is 12, okay? This, however, is not 6, this is 5 because this piece would connect right here. This is also 5 because it would connect to the other one. These are all 12 all the way across though. So if I wanted to find the area, so when I find the surface area, I'm finding the area of everything. So all the 3 rectangles, so the 3 faces, and then the 2 bases there. So I have 2 triangles here, so the area of my triangles is 2, and then I have 1/2 the base, which is 6, but now I need the height of that triangle. Well, luckily for you, I split that in half to find my height, and I get a 3 here and a 5 here, so you don't have to use any of your trig functions. You have 2 sides, and it's a right triangle, so you can use the Pythagorean theorem. Or you just remember it's a Pythagorean triple, so then that would make your height 4. So then my height's 4. So my 2 triangles ends up being 24. So these 2 areas right here end up being 24. The area of all my rectangles, oops, that's supposed to be an area, not a triangle, is, so this one is 6 times 12. And then this one is 5 times 12. And then I have another one that's 5 times 12. So together that gives me 192. So the area, the surface area of the total is 24 plus 192. So I get 216. This is still area, so it's centimeters squared. Okay? All right, the lateral area. If I just wanted to find the area of the 2 bases, I'm sorry, if I wanted to find the area of everything but without the bases, what I would do here is I would just be finding the area of the rectangles. So what I could do here is I could find, if you think about this, I have one big rectangle right here with the side that's 6 plus 5 plus 5. So that is just the perimeter of that triangle. So the lateral area of a right prism is the product of the perimeter of the base and the height of the prism. So it's just the perimeter times the height. And then the surface area of a right prism is the sum of the lateral area and the area of the two bases. So again, if you find that lateral area, you then just add on the two bases. So lateral area plus 2b, 2 base. And that capital B is going to be used to represent the area of the base. So if I go back up here, if I did my lateral area, so again, I'd have 6 plus, so my perimeter would be 6 plus 5 plus 5, and then my height is 12. So I'd have 16 times 12. So there's my 192, which is what I had for a rectangle. And then here, if I found the area of the two bases, that would still be that triangle right there. So I'd get the same answer, okay? So you could use that idea here. It says we wanted to find the surface area here. So to find the surface area here, if I use the formula I gave you just on the prior page, so the lateral area is the perimeter times the height. So these hexagons right here are the bases because those are the parallel faces. And it looks like the side there is 6. So I have 6 plus 6 plus 6. So I have 6 of those 6s. So my perimeter is 36. The height is that distance right there, so it's 12. So my lateral area is 432 meters squared. So that's what's going to go into my lateral area formula. The area of my base. Ugh, those triangles, they keep coming back. So one of those bases right there. So remember, to find the area of this polygon, so area of that hexagon right there, which is also my B, remember, it's 1/2 the apothem times the perimeter. So we said the perimeter was 36, but we need to know what the apothem is, or opossum, whatever you want to call it, the A. Okay, so we have that triangle right there. That triangle up there, that angle at top of that triangle is 60 degrees because there's 6 triangles in there. 360 divided by 6 gives me 60. If I split it in half, the half angle is 30 degrees. Down here I've got a 60 degree. This half side right here is 3, so that's the short. So there's my apothem, my height of this little triangle is 3 square roots of 3, so that goes right there and there. It says I'm going to leave my answer in simplest radical form, so I'm not going to multiply out the radical. So 54 square root of 3. So now, over here, that's my area of my base. So now when I find that surface area, so it's my lateral area plus 2 bases. So my lateral area is 432. I have 2 of these 54 square roots of 3. So if I leave my answer in simplest radical form, it looks like this. 432 plus 108 square root of 3 meters squared. And if I round it, I'm running out of room. I didn't space this very well. If I round it here, it's approximately 619.1 meters squared. Isn't that fun? I just went sideways. Okay. All right, a cylinder is a solid that has 2 congruent parallel bases that are circles. So a cylinder is like a prism, but the bases are always circles, so we just call it a cylinder. All the other terms are very similar. So we have bases, we have a lateral face. So the bases are here. We have altitudes, which we find the length of to get our height. Again, you could have a crooked one, so an oblique one. Right just means they're straight up and down. So then the altitudes are outside, but it's still the straight perpendicular height. All right, if we think about the nut of a cylinder. So we have those 2 bases, and if you open up around there, what does that look like? It looks like a rectangle. So if this base has a radius of r, and this is probably not very good, but if I do 1 revolution right that, this side is going to be 2 pi r, it's just going to be the circumference. And then the height, it has a height there. So this is just a rectangle. So when I want to find the lateral area, it's the product of the circumference of the base and the height of the cylinder. So instead of perimeter times height, it's circumference, so it's 2 pi r times the height. I just made the h curvy just because. The surface area is, again, just like we said before, your surface area is still the same idea before. It's still the lateral area plus the two bases, but in this case, the lateral area is 2 pi r h. We know it's always going to be that because the base is always a circle, so the lateral area is always a rectangle. And again, since the base is always a circle, it's just 2 pi r for the 2b. Remember, this is right here is the area of a circle, there's two of them. So if we have a height, so my h is 9, my radius is 10. It says leave my answer in terms of pi. I want the surface area. So this one I don't really break up. So it's 2 pi 10 times 9 plus 2 pi 10 squared. So here we've got 180 pi. We've got a 0. And here we have 200 pi. So I end up with 380 pi centimeters squared, because again, we're finding area. Okay? Alrighty, that is it, people. So you've got the 11-1 homework and the 11-2 homework to do right now. So go at it, and I'll see you tomorrow.